Embeddings are nothing but converting data into what nana vectors. See, in any ideal scenario, we need to convert text or image, anything into what nana vectors, because system can understand only what nana numericals. Systems can understand only numericals. So once you create the embeddings, we need to store the what we need. We need to store embedding somewhere. In order to store the embeddings, we use vector DBs. It is not the SQL DB. It is called the vector DB. Is exclusively for vector embedding. Once you store the vectors, next step is what nana? Retrieve the information from vector DB. We want to extract the relevant information from the vector DB. Okay. This is what the vector DB. This is what the embeddings. This was the vector DB. This was the search. Search will happen against vector DB. Okay. Turn image audio vectors into this. Object vectors, object segmentation, scene detection. Text will be translation, question and answer, semantic search, speech to text, music transcription, mission malfunction. Write down this. Heading raskunar kada embeddings adi. Similarity search. Use case for vector DBs. The diagram istunar kada ninna. Search and this is drag flow. What is this nana? This box is what nana? Red box. Drag. Vector search strategies. Vector search. How do you search the vector? By using approximate neighbors and tree based and HNS-W, by clustering, by hashing, locality sensitive hashing. It meaning of that the most of the searches happens with FIAS and HNS-W, and HNS-W is high navigable small world. Hierarchical navigable small world algorithm. What is this, Nana? HNS-W is high navigable, hierarchical navigable small world graphs. Okay, last one. Search strategies. We need to search more efficiently, or we need to scan entire thing? We need to search more efficient manner. Okay. You know this one, right? L1, L2 distance, we know it, right? Do we know it or not? Compression vectors into product quantization. FIAS. What is this, Nana? FIAS. See, FIAS works based on what, Nana? L2 is Euclidean or L1 is Euclidean? L2. Distance between all points to the query vector. For a given query vector, identify which cell is belongs to. So for a query and all the data points, right? It finds the Euclidean distance and find out all the vectors to belongs to that particular context. So limitation. Limitation is not good for sparse vector, means that if you have more zeros and ones, it cannot work. It cannot work. FIAS is built on 2015. It was there in since when, Nana? 2015. So he is trying to find Voronoi cells. This is the one. This is the one. This is the one. Centroids. This is the one. This is the one. And it will be grouped under a one. Grouped around one. This is the very simplest method to extract the what, Nana? Similarity search. Write down. Belongs to that query. Cell and rayadand belongs to that query. Third point, belongs to that query. Okay, This is your skip list algorithm. What is this, Nana? HNSW will be your skip list mission the data structure algorithm. Uses what, Nana? Linked list. ఏమి ఇక్కడ వాడుతున్నాం మనము? Linked list. అందుకని అప్పుడు అన్ని చెప్పింది ఎందుకు? ఇక్కడ వాడతారా బాబు, ఏఐలో వాడతారు అని చెప్పింది. What is this, Nana? Adding filter to the functions is hard. Not only like in additional, so post query, pre query, post query filtering. What is this, Nana? Post query filtering. Right on this post query filtering. దీనివల్ల ఇష్యూ ఏంటంటే రిజల్ట్స్ ఆర్ హైలీ అన్ప్రెడిక్టబుల్. ఏదంటే డేటా తీసుకొచ్చేస్తారు. ఓకే, వాట్ యూ నీడ్ టు డూ? Inquiry filtering. Again, here you need to do the two filterings: query, search, then filter. In this process, post query filtering. Once you get the data, again you need to apply the filters. That is what after the query fetches. Otherwise, you will get the mess up data. What are the similar questions? Movie questions అడుగుతున్నావు, ఇన్వెంటరీ లైన్స్ తీసుకొని వచ్చింది, అంత డేటా వచ్చేసింది, దాని నుంచి మళ్ళా స్టూడియో నేమ్ ని ఫిల్టర్ చేస్తుంది. ఫ్రోజన్ అనే నేమ్ తో ఇక్కడ అన్ని వచ్చేసినాయి రిలవెంట్. మళ్ళా స్టూడియో నేమ్ అనే దాన్ని ఇచ్చి మళ్ళా ఫిల్టర్ చేస్తున్నాం. పోస్ట్ క్వైరీ ఆఫ్టర్ రిట్రైవల్, అగైన్ యు ఆర్ అప్లైయింగ్ ద క్వైరీ. పోస్ట్ క్వైరీ ఈక్వల్ టు, again you are filtering and you are getting the answers. This is the post, right? This is the pre, right? Understood or not? This is the post query method. Inquiry, compute both the product similarity and filters simultaneously, which is good, right? Which is the faster. OOM stands for out of memory. Sometimes you will get the out of memory. Inquiry filtering is the issue. Okay, this is not good for building retrieval of the data. Most appropriate is pre-query filtering. This is also not proper one. The first approach is good. First approach is get the data, again filter. Not performant as the post or inquiry, right? So it meaning of that post query and inquiry as good ones. Agree or not agree?